So this is a continuation of particle motion review. Again, this is not a lesson where I'm teaching it. This is a lesson where we're going quickly to see if we understand the concepts and complete a problem. I copied the book problem. The function here is S. Okay, so this is the position function. If you pause the video, you should try these questions ahead of time. I am going to just enlarge the answers and quickly discuss them so you have an example problem to work from. All right, so I think the easiest one on here might be letter A. If you understand particle motion, you know that the position function, feet versus seconds, means the slope of the tangent line is feet per second. So you just take the derivative, S prime. So for letter A, this is the answer. All right, it says what is the velocity after 1 second? So all you have to do for that is to put 1 second into the velocity equation. All right. And we see that the velocity, if you put 1 into this equation right here, it comes out 11. Read the instructions. The instructions say distance is in times in seconds, S is in feet, so you have to have units, feet per second. You got to have units. Then it says, when is the particle at rest? All right. It's important for us to understand right now that the particle at rest means velocity equals 0, and we should write that. Whoops. All right, we should write that. And when I gather that stuff there, and I put it over here, boy, it's been a while since I did this, but I better have written that first. Oh, and I did, for letter C. So velocity is 0. First thing I write, I put it on there, I say, hey, velocity is 0. So now, this didn't factor. I checked it, it didn't factor, so I tried to complete the square. And lo and behold, I get a negative number. Guess what that proves? That proves the time that the velocity is never 0. It proves that if you think of this function, that 3t squared minus 16t plus 24, it's a parabola. Well, it means it's above the x-axis. I don't know where it is yet, but I guarantee it goes like this because there is no 0. So guess what? I can quickly also see that if I think of v of 0, the y-intercept of that, I put 0 in here, I'm going to get 24 feet per second. So I know this particle is always going forward. All right? It might not go forward as fast. The parabola, I think, has a vertex to the right of the origin, so I think it slows down, but then it speeds up, but it never has negative velocity. So when is the particle rest? Never. It is always going forward this time. When is the particle moving in the positive direction? Well, we just talked about this. It's always moving in a positive direction from t equals 0 on. And I needed to check 0 for that part. Okay, I had to make sure it was positive there. But the velocity is always positive. Find the total distance traveled in the first 6 seconds. All right, so we have a situation now where we have a position function. So the first thing I do if I want to know the first 6 seconds is I better know those positions, right? At S sub 0 and S sub 70, S sub 6. And I did that here. I'm going to make this a little smaller so we can all see. So, for letter E, I know this. I know it's at 0 at 0. I know it's at 72 at 72. All right? I also know the graph and position. I also know the velocity never changes direction. It's always going forward. So think about it. If you are at 0 and the velocity is always going to the right, do you ever start going back on the number line for position? You don't. You always going to the right. It's always getting bigger. So this is one of those odd cases. I will tell you that you are at a position of 72. You start at a position of 0, so the displacement is 72 because that's the difference of these two, but also the distance is 72 feet because it went one direction, okay? Draw a diagram like figure 2 to illustrate. This is, for F, this is the diagram. They're saying that we know at time 0, we are at 0. And this particle at time 6 is at 72. And then we know this is the diagram. It's really a simple one. It never does, it doesn't double back. It never does any, an S. It never does a little S motion, all right? So it just goes in one direction. And again, those S's would be velocity equals 0 positions. So there's letter E and F. Find the acceleration at time t in 1 second. Well, time t, take the derivative of velocity. So up here is F. Or, I'm sorry, not F, G. Find the acceleration. So it's A sub t is 6t minus 16. If you want to find it at 1, just plug in 1. 6 minus negative 10 meters per second squared. Again, units, not meters, feet, sorry. Feet this time. It could be meters, could be centimeters, but you got to check the word problem. It asks us to graph the position of the velocity acceleration functions from 0 to 6. I got a little lazy and used Desmos, and I'm going to write here right now that this is S sub t, so you can see it. This is V sub t, and this is A sub t. Now, S sub t was a cubic. You can kind of see the cubic shape to the blue. V of t was t squared, parabola. There's the parabola. A of t was a line. So you can easily pick these out just based on shape and mothers. I'm going to window in here so we can talk about when it speeds up and speeds down. I think this is absolutely a place where you'd want to use technology to do the graphing. All right, so we are on the last little bit here. All right, remember our rule. If the velocity is positive and the acceleration is positive, you're speeding up. If the velocity is negative and the acceleration is negative, you are speeding up, because speed doesn't go with velocity. Velocity has a direction, moving right, moving left. Speed doesn't. You can speed up driving in reverse. So, if I turn on my highlighter here, I want to be clear. This is negative acceleration. So if the speed's going to be increasing here and you have a negative A, you need a negative V. Well, guess what? V is always positive in this problem. We'd already determined that. So it is not speeding up here. It is actually, the speed is going down here. But at this point where A is equal to 0, and the A of t equation, right, was, I already forgot it, so I gotta go up and glance at it. It was 6t minus 16. If I say, hey, I want to know when A equals 0, right, it's 16/6, which is 8/3. This time right here is 8/3. All right, when velocity is 0, or acceleration is 0, I'm sorry, velocity is not increasing or decreasing. You're just going at constant speed for an instant. But I will tell you, after that instant, we have a positive velocity and we have a positive acceleration, both go in the same direction. So when is the particle slowing? Oh, when is the particle speeding up? It is speeding up from 8/3 to infinity, because you can see they both go off forever and ever. When is it slowing down? If it's not speeding up, and it's not 0, it's slowing down. So it's slowing down. It is slowing down at 0. So I put a bracket, because at 0, boom, right? It had negative acceleration, positive velocity. It is slowing down. To where? To 8/3. With an open bracket. All right, again, these problems are difficult. You can practice them. They take a lot of practice. Don't give up. All right, I'll get this posted on YouTube.